Okay, this is problem 4. It has an x in the exponent, so this means it's an exponential growth or decay problem. We're looking for the end behavior, so what it does on the far left and the far right, whether the graph is going up or down in those places. So again, it's a good idea to get a graph. Because of the 1/4 to the power of x, since this number is smaller than 1, in between 0 and 1, it's going to be exponential decay. So the overall look of this is it's going to get really close to 0. There's an asymptote there, but it'll never actually touch it. The +2 is going to make it go to the left by 2, and the -1 is going to make it go down by 1, which is important because there's a horizontal asymptote right here, so that will scoot down by 1 as well. So if we make it go to the left 2 and down by 1, it's actually going to go through this point, and our horizontal asymptote has now scooted down by 1. So our actual transformed graph is like this. And the end behavior is, notice all these things say as x goes to -infinity. So it's saying as we're going to the left, what's the graph doing? Well, the graph is going up. It's going up forever. So our two options that match that are C and D. And then all the options again say as x is going to +infinity, so that's saying as we go to the right, what is the graph doing? Well, the graph is getting closer and closer to -1 because the asymptote is now at -1. It scooted down by 1 from where it was. And so our answer is C. You can also graph this in your calculator. Just make sure you use good parentheses. So 1/4 to the power of parentheses again, x plus 2. Close your parentheses and then -1. So it tacks it on at the very end, and it'll show the same graph that we drew by hand.